Welcome to Modern React is all about hooks. So let's just quickly talk about the different hooks that exist in a nutshell. We'll start off with the most basic, of course, which is useState. You can use that to store local values that are maintained between renders. You've got useEffect, which replaces all of the component lifecycle methods that exist in a class, and they're run after the render has occurred, but obviously still within the component lifecycle. We've got useLayoutEffect, which is the same as above, but it's not run after render. It's run immediately after any DOM mutations have taken place, and it's synchronous. So if you use it, there's a chance you could block the browser from painting. So you'll probably never use it, but in the interests of being thorough, it's included on this slide. Then we've got useRef, which you can use to maintain a reference to something, just any value really. Most often, I would argue it's probably used to maintain a reference to something rendered in the DOM. There's useMemo, which you can use to memoize expensive computations. I'd probably argue myself that that is an API concern rather than a front-end concern, but it's there if you need it, is probably the key takeaway. If there is something you need to take care of in the front end, you can use useMemo to cache that value. There's useCallback, which is the same as above, but it's to memoize functions. So if you want to maintain the same reference to a single function between renders, this is where you would use useCallback. There's also useReducer. You would use that for managing more complex state. So for when your state isn't enough, basically, or it's becoming cumbersome to manage, you can implement useReducer. Though I'd probably argue that at that point, maybe it's worth thinking about Redux or similar. And finally, there is useContext. So you can use this to consume a React context that you've created elsewhere, which is another form of data store, I suppose, is probably a good way to think about it. So of these hooks, useState is pretty straightforward. I don't want to spend too much time thinking about that. useEffect is probably the most useful outside of useState, and I would argue what you will be using the most in terms of these hooks that come with React. And so that's what I want to talk about. And the special sauce of useEffect is in its declaration. It takes two arguments. The first is required, the second is optional. So the first is just a function to run. And for the most part, you would declare that as an anonymous function rather than writing it separately and saying, hey, use this function. The dependencies is, yes, as mentioned, it is optional. It is an array. And that's really where a lot of the magic happens in useEffect. And while I think useEffect is definitely the most useful of these React hooks, and so while useEffect is really powerful, it's also really easy to get yourself into a spot of bother and have infinite renders and so on, and generally a bad time. So let's talk about when these effects are actually run. So the first, this is run on every single render of the component, because we've provided it no array of dependencies. So it just goes, oh, I've updated, I've got to rerun. And so every time this component is rendered, it's going to console log every render. It's pretty uncommon to do this, and you would probably not want to use it unless you had a very specific use case in mind. The second option for when effects run is only on the first render. And you can achieve this by providing it an empty array of dependencies. And so you might use this to update the document title. And so this would run the first time that this is rendered and just update the title to rendered. Not a lot to speak of there. The third, and I would argue most common use of useEffect is with dependencies. So here we have a component with props being passed into it, and we grab value out of those props, we're destructuring it. And so this effect will run on the first render, and in the case that value itself changes. And so typically speaking, if you're making a network request or something to that effect, you'll add your dependencies into this dependencies array, such that when it runs and that might cause props to change, it doesn't actually then run that effect again and run the network request again, and then get data again and then update again. And you can see that this would ultimately end in an infinite loop of renders. And so that covers the mounting and updating parts of the component lifecycle with useEffect. The final phase we need to think about is cleanup or unmount. And so in a function component with useEffect, you can return a function. And whatever that function is called when the component unmounts. And so here's an example where we've got a timer, we set a timeout, and when the component unmounts, we just want to clear the timeout, because if we don't, there's potential for memory leaks to occur in the application. And so this brings us to the next point on useEffect, which is co-locating lifecycle logic. So if you've got a class and you've got that same timer example, you would need to implement it like so. You've got timer up the top, you initialize the timer in the mount phase, and then in unmount, you clear the timer. And just to show that same example again with a function component, it's all in the one place. So we set up the timer and everything it needs to do immediately in useEffect. And then on unmount, where we have a return statement with a function that gets called and it clears that timeout. Another probably more real world example is as follows. We've got a class component with state holding a count property. On mount, we set the document title to uclicked count times. And then on every subsequent update, we're also going to set it to uclicked count times. So we've got duplication of logic there. You can see here, just down in the render method, on click, we set state to count +1, or we set count to count +1, I should say. That will trigger a re-render. It'll update the title. So in a function component, this is what it would look like. We're still managing some state in the component. Then we have useEffect that is run every single render, which you can see because it doesn't have a dependency array. And then again, we've got that same button with an on-click, set count, count +1. And so you hit the button, the component re-renders, it updates the title. So less duplication to think about there, less code to manage overall. There is one function component gotcha that you need to be aware of, and I've sort of alluded to this a little bit in the past, and that is that every time a function component gets re-rendered, it's a new copy of that component, including all the functions that are declared inside of it, your event handlers and so on. And sometimes that's not particularly desirable. Generally it's okay, but not always. And so the way to get around that is to wrap your actual function in useCallback, as you can see here. And we're not providing dependency arrays, but you can, depending on if there are certain conditions that it needs to be reinitialized under. So that's useEffect and how you can co-locate lifecycle logic, and a practical example of how to stop everything being recreated on render in events where it's desirable. So I want to talk about sharing logic with hooks, custom hooks that is. So let's first establish the problem. I had 3 minimally different registration pages with 5 to 6 fields. 2 of those required validation, email and password, of course. And these components all started life as class components as well. And so I looked at these components and I asked the question, what's in there that can be moved out and just imported and used where need be? Validation was the first answer, and really the only answer, if I'm being honest, for this given case. And let's not criticize that email regex. It is obviously very simplified because otherwise it won't fit on the screen. And so then in a given registration component, and again, this is a very, 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 very simplified version of the registration component. We've got the name, email, and an email valid property in state. We've got a change handler where we look at what's coming in, do we need to validate, and so on. The submit handler is just included for keeping it more complete than it would have otherwise been. And so then in our render method, we've got a form, we've got inputs, and so on. And so this was all duplicated across 3 different components, and it was a real nightmare to manage. Then hooks came out, and they were really, really brilliant game changers for sharing component logic. So let's move along and have a look at how this component would exist as a function component. It's declared the same way. We're managing the same data in state, but we've split it out and managed it separately. I'll also note you can store objects, arrays, etc. in state. It's up to you. I probably prefer doing it this way for something like a registration form, but go with whatever's conventional in the project that you're working in. And so we don't need change handlers anymore. We still need a submit handler. And so if we move down a bit and look at the name input, we're calling onChange, but we're just going to call set name in line there. And then the email input, we have an onChange handler declared in line. We see if the email is valid. We set the value of the email, and then we set is it valid or not. And so comparing the function to the class version of the registration component, there's not really a lot going on to differentiate between them. The function component is maybe a bit simpler. It depends. Some people don't like having the onChange handler in line like that. When you're just setting the name, I think it's perfectly acceptable. It gets a little bit weird and maybe even a little bit gross when you're doing a lot of work in line. But generally it's okay, and you're probably never ever going to notice a performance hit for it. Anyhow, the problem still exists. I still have all this duplicated logic across 3 components. And this is where I decided to move it out to a custom hook. So I've created a custom hook here, as you can see. I've got another function called setEmail, which does everything we saw back in the function component down here in line. We validate the email, and then we set both the value of email and if it's valid or not. And I've just prefixed the set email that stores the value of with an underscore to indicate that it's private in this context. And down the bottom, we can see I'm returning an object which has name, set name, valid, and set email. I'll also just quickly note that it is convention to name your hook, whatever it may be, but it starts with use. And so moving into actually using this hook, it'll look a little bit like this. At the top of the component, we're calling use registration, and we use object destructuring to grab the properties out that we want. Still got a submit handler, but though you could also put it in there depending on your use case, also put in the hook that is. And then for the actual form itself, we've got the form tag with the onSubmit handler. We've got 2 inputs, same as before, one for name, one for email. And we're just calling those functions that need to be called in order to update state. And so that allowed me to drastically reduce the complexity of 3 components that otherwise would have been very difficult to do in a way that is modern and understood. And if you ever need to share logic, I strongly encourage you write a custom hook. There are many, many, many use cases for them. But in any case, that's the end of this series. So in summary, understand the component lifecycle, write functional programming style code, use tools like Create React App and so on to spare brain power, keep yourself effective and efficient. Always create conventional and consistent component APIs, write semantic HTML and use fragments, think about accessibility and stop polluting the DOM with unnecessary amounts of divs. Always be destructuring, communicate your intent clearly from the get-go. Decompose components into smaller components when it makes sense to do so. Prefer function components and hooks over classes and higher order components, and write custom hooks to prevent repeating logic. The end.